Well, this is areas of rectangles. I really hope you guys have that down by now, for 980 class. But if you don't, just in case, it's the area of a rectangle equals length times width. Now, I don't usually write the words out. I prefer to see it as, that's not an L. Let me try that again. There's an L, and then a W. I think those are pretty fancy W's. I mean, letters, they almost look like cursive, but these are the formulas we're going to be needing. So on this one, what is the height of a rectangle if the area is 345 square feet? And again, the units don't really matter, you guys, because the formula is still the same. So the area equals length times width, and that's L. Sorry about that. But this one, it gave us the length up there at, what is that, 345? I used the wrong color. There we go. 345. So I can replace the A, which is the area. And, hopefully you guys have seen this where we can evaluate formulas like this and replace letters with numbers. Now the 23, I really don't care if you choose it to be length or width. I just have my marker on red, so I'm going to make it the length, okay? So we'll change the length and make it 23 right there. I put it in parentheses. I mean, that's not even required right there. You could just say it's 23W, right? In which case, we've created an equation which is just one stepper to solve, where we divide both sides by 23, right? So I'm going to go to my calculator because I'm not familiar with my 23 multiplication tables. 345 divided by 23, 15. But here's another thing. If we were still writing things instead of doing it on the computer, make sure you label that garbage. So yeah, the width on this one, or height, if you want to call the width height, it's the same thing, okay? But yeah, it's 15 feet either way. To answer that question, so the original area was already given to us in square feet. So when it asks for the height, we're only specifically looking for length. And so lengths or widths or heights, we only need to describe those in single units of, in this case, feet. All right, area of composite shapes like this one. Now, you may ask, what is a composite shape? It's just a shape that's made up of more than one shape. In this case, we're really looking at two rectangles. Now, some of you guys would be like, dude, I want to cut it diagonally and then make two trapezoids. If you want to do that, go ahead. I'm not going to. But you're welcome to. What I would like to do instead is just, I want to cut it either vertically this way or horizontally this way. So which way do you guys want me to cut it? Horizontally. So we're going to cut it. I'm going to cut this rectangle out. I'll move it even if I can get this to work. Move it over here, and then that would have left the cut here, right, for us to create this rectangle, which again I'll move it down here. There we go. So now that I have those moved away, I just need to label the edges based on what they were before, right? Like this one was 4.8 feet, and this one was 9.8 feet. And this one's 3.5 feet, like this. Now, the second edge of that purple one, I don't know it yet, so I need to actually figure that out. And the way that you do this is you'd say, look, this is 10.1 feet right here, which is good. And then we know that this length is 3.5 of the 10.1 feet. So, actually, let me see if I can redo that. Yeah, this one right here. So if I moved it over here, it's parallel to that 10.1 feet. And there we go. But it takes up 3.5 of the 10.1 feet. So that's 3.5 there. What I really want then is this length, which is that part of the rectangle. And to figure it out, I'm going to have to take 10.1 and subtract 3.5. So that's going to give us 6.6 right there in feet. So this one here, 6.6 feet. Now we want the area, so we got to multiply length and width for both of these rectangles. So the area of the purple one is going to be 4.8 times 6.6, And I'll just put that in my calculator real quick. 4.8 times 6.6, 31.68. And then the red one, same thing, length times width, so 9.8 times 3.5, which in my calculator is 34.3. So I'm going to take these two values, the area of these two rectangles, and if I add them together, it would give me the area of that full shape. So 31.68 plus 34.3. And this will add up to 65.98. And this one, since it is now asking for area, we would label this one in square feet. Right there. I may or may not finish this, but another way to do this, you guys, is to look at this entire thing as a giant, not giant, but a big rectangle right there. And then you've got side lengths of 9.8 and 10.1, right? So you'd say, well, the area of the green one is 10.1 times 9.8. And then that, what does the calculator give us? 10.1 times 9.8. Now, this 98.98 square feet is for the whole green rectangle. However, there's part of it that's missing, right? It's this part, which is 6.6 by, 5, looks like. 6.6 by 5. So the orange one, the orange rectangle right here, it doesn't actually exist in the original shape. So you do 6.6 times, 6.6 times 5, which is 33. So that's 33, but it doesn't exist, right? So you just have to subtract that out. And when you do subtract that from 98.98, it gives you 65.98, which is what we got before. So it's just a quick second method, which if you guys want to use, you could. It's another composite shape. Hopefully we can see the two. Here, I'm going to make this a little bit smaller. Hopefully that makes this a little bit easier to work with. So the two shapes I'm going to split this up into is this rectangle here. And yeah, I'll move it over. There we go. And label it. So there's an 8 and 10. And we don't really care what the units are on this. Like, again, it could be feet. We could even label it just strictly as units if we'd like to. But then it's been split up also into this triangle that's just sitting on top of the rectangle. So I'm gonna move this down here as well. And we'll look at the formula for the area of a triangle here in a second. And we know that the height of this triangle, which is crucial, we need the height, is 5. And this is where a lot of students get confused is, well, what's the width of this triangle, or the base value of the triangle? It's this 8, you guys. It's the same 8 that would be right here on the original shape. So it's 8, it's kind of like an 8 by 5 triangle right here. Now, if we wanted the area of a triangle, it is length times width, just like you would with a regular rectangle, but it's half of that. All right, so you'd multiply this out, and then would find that it's 20, you could say 20 square units. It's area, so we know it's square units one way or the other. And then we can find the area of this rectangle, which is 10 times 8, which is 80 square units. So to figure out the total area of the whole thing, we'd take the 80 and the 20 and just add them together, you guys. So the total area of this one would be, I'm going to show it as 100 square units, like this. And that would be the final area of the original composite shape. What is the area of the square? What is the area of the circle? What is the area of the blue section? And if the sides of the square are 10 feet. Oh, okay, so they gave us at least some dimensions to work with. One thing we need to understand about this is it is a square. So even though it may not look like one right now, it's a square. So I should only have to label one of the sides, but I do like to label at least two of the sides, especially when we're dealing with area. So the square, as it turns out, I need a little bit more space here. is just, it's a 10 by 10 square. So I would just type this in as 10 times 10, right, in my calculator, and it would show me that it's 100. And again, we're looking at feet on this one, so feet squared. If you write it as square feet, it works as well. Now the circle is different. To find the area of a circle, we actually need the radius, and we can see hopefully the relationship between the radius of the circle and the length of one of the sides of the square. The radius is just half of that, you guys. So the radius of that is 5 feet. Now the area of a circle is where we take pi and we multiply it by the radius to the power of 2. And we just saw that the radius on this one is, well, it's 5. And actually for me, I prefer more exact values. So on my calculator, this is the TI-30XS multi-view. If you go to the top left to that second button, the pi button itself is actually 3 buttons below the second, that green button. It's a nice fancy Greek pi. Actually, that makes me hungry for some reason, but pi, right? I got pi, and then I'm going to multiply that by 5 to the power of 2. Now when I push equals in my calculator, it told me the exact answer as 25 pi. I don't want the exact answer. I want an estimation, and I'll round it to the nearest hundredth. To do that, just right above the enter button in the bottom right is a double arrow button. If you push that button right now, the calculator will give you the estimation as far as it can with a decimal. So mine is showing me 78.53981634. I said I would round to the nearest hundredth, so that's 78.539, so I'd have to round that to 54. And again, that's in feet squared. I ran out of space there. So there's the area of the circle. So to find the area, that's not very blue, it looks more gray, but to find the area of that blue section, all you'd have to do is take the area of the square and subtract the area of the circle. So yeah, I'll type that into my calculator. 100 minus 78.54, and I get 21.46. And again, this is in square feet for that one. Yeah, that's the answer to the third part there. Now, if I remember in the homework, they do give you this formula because it's an open box, and we have to define length and width as one part of the box. Okay, so just so we understand what's going on here, an open box, we're not actually counting the top part, but it should have the 2 sides and then the 2 other sides and then the bottom of the box. The top is empty, otherwise would double the length and width right here. All right, now this one, yeah, 5 rectangles. I'm not going to draw a picture. I thought this was a problem. My bad. Let's go to the next problem. Like this one, same formula though. It's just that the surface area, that's what we want to find. It's an open top box, so we are using this formula. The length is 12 centimeters, the width is 3 centimeters, and the height is 9 centimeters. So since it is surface area though, the label for the answer is going to be in square centimeters. But yeah, let's go ahead and use this formula. So it's 2 times the length times the width, and we'll fill these in as we go, plus 2 times the width times the height, plus the length times the width. And they told us the length here is 12 centimeters, so I'll just replace all the lengths with 12 there. And it says the width is 3 centimeters, so wherever I had a W, I just replace that with 3. And then finally the height was 9, right? So I replace all the H's with 9s. Now you could evaluate this with the order of operations. It's just, we're in 980 now, so the calculator knows the order of operations, so I'm actually just going to type this in exactly like I see it. So that's 2 times 12 times 9 plus 2 times, oh, I pushed the wrong button, dang it. I got to start over. 2 times 12 times 9 plus 2 times 3 times 9. What is that? Yeah, that's the right one. Plus 12 times 3. There we go. And my calculator, again, I just typed it all in at the same time. I didn't push enter until the end, but it gave me an answer of 300.
Sorry.
No, that's not your guys' fault, but it is. You guys are right. It is 306 square centimeters. I just typed it wrong into my calculator that first time. A couple other objects we may see are cylinders and cones. So R for the cylinder and the cone is radius, which would be the radius of the circular part of the cone or cylinder. H is the height, which really is what gives the circle its depth. The only difference between a cylinder and a cone, you guys, is that a cylinder, or a cone rather, is just a third of a cylinder. Like if you had a cone with the same dimensions of a cylinder, you could pour it into the cone, it would take 3 pours and you'd be... The only reason I bring that up is because if you're looking to memorize these formulas, that's how you would do it, I suppose. But this one, it gave us the formula right there, and it says find the volume of a cylinder with a radius 7 feet, and the height is 20 feet. We'll round to the nearest hundredth as we need, and we'll always need to round with pi because it is a irrational number. The decimal goes on forever without repeating. So there's our formula right there with pi. And they did tell us the radius on this thing, which is 7 feet right here. So again, I just replaced the R with 7. And then they also said that the height was 20 feet, so I replaced the H there with 20. And this is volume, not area. So whatever units we get is going to be cubed. It's cubic units. And like I said, you can type this in, pi, into your calculator with the pi button. Pi times 7 to the power of 2 times 20. It should be a pretty big number. And again, mine gives me 1,580 pi. I push the double arrow button right above the enter button, which, 980 pi, and just changing it into the decimal form like you guys have there. I got, and I'm using, it sounds like some of you guys are getting lower values, and that could be because you're using 3.14 instead. I'm actually using the pi button, which is giving me a very different answer. Not very different, but slightly different. Mine's showing 3078.760. So I'm going to write this as 76 right there. And again, this is in cubic centimeters here. Feet rather. But you guys can be a little off if you use 3.14 for pi. It's just more typing in my calculator than I want to do. And yes, I know I've made a few mistakes with my typing on this one, which is why I try to type even less than I probably should at sometimes. So yeah, if you were off by, well heck, what do you get on that? 3.14 times 7 to the power of 2 times 20. Yeah, it came out as 3,077.2. It's off by 1 and 1.5 cubic feet right there, which in context of 3,078 cubic feet really isn't that much anyways. So if you got that answer, it should still work. All right, let's figure out the volume of a cone then. Again, I'm going to use the formula. Most students like that second one, pi times the radius to the power of 2 times h all over 3 like this. And just like the last one, they gave us the radius here at 9. And yeah, I'll try to type this in correctly this time. In fact, I'll make double sure of it. But the height is also given to us at 8 feet right here. So again, I'm just typing it in. I got pi times 9 to the power of 2 times 8, and then I got divided by 3. So I almost put divided by 2, you guys. I almost made a mistake again. So this one's showing me 216 pi. I push the double arrow button, and it gives me the decimal 678.584. So again, that should just round to 5.8 right there. And again, this is cubic feet on this one. If you consider both, right? Like, if you were just to take out the stuff that is similar between those two formulas, like if I just erase this stuff, right? It's like, well, what is the difference between 1/3 multiplied by something or something divided by 3? As it turns out, there really is no difference. It just depends on the way that you prefer to see it. And that goes back to what I said before about you taking control of what it is that you want to see in these, because they're the same. Like, it doesn't matter whether you write 1/3 times the stuff like we have here, or if you just take the stuff and divide it by 3. And part of that is, like, if I were to take this stuff away, let's see if I can do that. There we go. That seems to be working. It's pretty much just fraction multiplication that converts that into that second fraction right there. So right? You take this, you take 1 times this stuff, which gives you pi r to the power of 2h, and then 3 times 1 is the 3 right there. So it's just a different format, a different way to write the original formula. And like I said, most of my students seem to prefer the second one, but some do prefer to do 1/3 times pi times r squared times h as well. Suppose that a cliff diver's height in feet after t seconds is given by this model. We don't have to calculate this, like if you were in a science or physics class, you probably would. We'll find the height after 2.35 seconds. Okay, hey, this one's not too bad actually, because we can use the calculator to calculate it completely. So I'm going to write it out just exactly like I see it there. All right, and then what did they tell us? Well, they told us it's after, we want to know the height after 2.35 seconds. And so, yeah, I'm going to replace the t's with 2.35. And I know I haven't forgot the squared was there. I just needed more space. 2.35. That was a t, and then the 2.35 there as well. That was another t. So again, the nice thing about this is I can type this directly into the calculator. I don't need to worry about the order of operations because the calculator already knows it. So I got 16 parentheses 2.35 close parentheses power of 2 plus 28 parentheses 2.35 close parentheses plus 49. And then I push enter and it gives me the answer at 26.44. And again, it said that the height was in feet, so I'll just label in feet. The last part of this section is just, it says solving equations for specified variables. In more specific terms, they call this literal equations because there's not really a lot of numbers that are included in the formulas. But if we remember our principles of equality, that's all we really need in order to solve these types of problems, okay? I prefer to call it something completely different. It's just equation manipulation. Again, this is about taking control and using your power to really force the equation to be what it is that you want it to be, because there is a lot of usefulness in being able to manipulate these equations and change how they look to fit what it is that you need. Like even if we looked at the volume formula, right, where it was, oh dang it, where it was V volume of the cylinder, right, pi times the radius to the power of 2 times the height. Well, look, if they give you the volume and the height, then you need to be able to manipulate this formula so that you can actually figure out the radius as well. But again, it all comes down to those principles of equality because these are still equations. So here's a few examples. One of them is the circumference. I like the second one. The second one has a lot more uses in 980 than they have in the other classes, where we're going to manipulate that equation for y. And you could manipulate it for x, but we'll see later on in one of the later units why manipulating for y is a little bit more useful. And then you guys see in number 3, that's the simple interest formula. So this one is circumference of a circle, 2 times pi times r, but if we wanted to solve for the radius, which means that we would have been given the circumference, then yes, I'm still going to apply a principle of equality, but I'm going to mold this how I want it to be so that it looks the way that I want it to look. If I'm solving for r, I need to get rid of that 2 pi, right? Which means that as of right now, it is a coefficient of r, the radius. So how do I get rid of that coefficient? You just divide it by itself, you guys, which right now is 2 pi, which then makes that a phantom 1r, and that would be the circumference divided by 2 pi. So if you ever saw a question that was like, here's the circumference, find the radius, you could use this exact formula. So in fact, let's do that one next, just because it is slightly related there. So this one says I equals PRT, and it says to solve for R. So again, I'm manipulating this equation. I need it to just be the R. And that means that I can't have the P and the T there. Now it's all multiplication, so what I need to do is make those P and the T phantom 1s. So I would need to divide the P by itself, and I'd need to divide the T by itself. Well, that's just really p times t in the denominator there, which means over with the I, again, to maintain equality, I'd have to have it divided by p times t in the denominator as well. So R, which would have been the rate for simple interest here, is going to equal the interest divided by the principal times the time in years. So the second formula, we got 2x plus 3y equals 17. Yeah, don't get that it's not 2.2 right there, all right? Now, I want to solve for y. So what I really would like to see out of this thing is just y equals something, right? Y equals something. I don't really care what it looks like. I just need it to equal, I don't want any other operations with y. I want it to be a phantom 1 there as the coefficient. So if I were looking at this like a regular equation, let's look at what it would look like as a regular equation, right? Like 2 plus, and I'm making this similar on purpose, you guys. 2 plus 3y equals 17. If I were to solve that equation, what would I do? I would subtract 2 from both sides, right? In order to isolate the y's by themselves. Now, the problem with the one that we're looking at is that we're getting rid of the 2x. It's not a like term with 17, so I can't actually combine those together. So this would be 17 minus 2x. If I were to relate that to the problem that I've done over here, that zeroes out, that's fine. But I've got 3y equals now, without simplifying the 17 minus 2, it would look like this. So see, the only difference is that in the equation we are actually working with is I can't combine these two because they're not like terms. So the last thing I need to do is divide both sides and all of the second side there, the right side, by 3. And that's how I would leave it. It's 17 minus 2x all over 3. Could you split this up into two separate fractions? You could. You'd have 17 thirds, sorry about my 7 right there, minus 2x over 3, and that'd be fine as well. And that would equal y. I like this one. I just, I don't know, it makes me feel good inside, I guess. Is if you go back to the beginning of this and you said, well, you know, we got, it's working. Come on. There we go. I didn't want all that there. Let me try again. All right, so let's go back to the beginning, right? 2x plus 3y, y, equals 17. Just be careful, because we can't just divide these two by 3. And that's partially why we need to isolate the y's in the first place. If you're going to do it this way, you're going to have to divide the 2 by 3 as well. Now that may further complicate things for you, but it essentially gives us this equation right here, which is the same as this one. It's just written in a different format. So like on a problem like this one where it says, hey, solve for n, well, identify where n is first, right? It's on the left side of that equal sign. Now that's all considered multiplication. So in order to solve for n, yeah, I need to zero out the L, I, and the n, right? So yeah, like if we look at this one, the L cancels out. Oh, it's working. It's common. There we go. The L cancels out as a phantom 1. Same with the I. And we wouldn't recommend using I in a formula like this. And the E cancels out, right? So we're just left with the N, which is what we wanted. But that, what does that equal? It equals math divided by, well, it's not lies at least. It's just a lie. That doesn't mean math is a lie. I thought it was more full of truth than anything. So yeah, on this one, actually I need the space over here, a little bit bigger. It says to solve for f, which is what we're going to do. So I'm going to isolate the f's, but that means that this entire term right here, I'm just going to keep it as is. It's its own term, right? Because terms are separated by addition and subtraction, which means the CA term I need to get rid of. So I need to zero out the CA because it's being added to that f term. And yes, I do need to do it to both sides of the equation. That zeroes that out, which is what I wanted, so it's a phantom 0 now. And on the left side, I can't combine those two terms, the L and the CA, because they're not like terms. So I'll keep that in mind doing this. So now I have L minus CA equals 3n minus 4 times F. Now, we should ask, because it is one term, what is the coefficient of F? The coefficient of F right now is that full set of parentheses, so I need to get rid of it or make it a phantom 1. How do I do that? I just divide both sides by 3n minus 4. Now, if it helps you to put that in parentheses, you're welcome to. I'm not going to because I'm a lazy math guy. So that's 1 right there, 1f, equals, and you guys hopefully can see that there's nothing else that I can simplify in this formula with the L, C, A, and the N. So that actually is the final answer right there. Whenever you solve literal equations like this, it's always going to look a little funky, and you may look at this answer right here, the L minus CA, and it's like, dude, I feel uncomfortable typing that into the homework. I feel like it's going to give it to me wrong, and I just don't know of any answer that's going to come out looking real fancy, because right now, yeah, it's like, yeah, that's pretty ugly, man. Yeah, this one says to solve for P. So this one with the P, I can see where it is. It's right here, and it's subtracting the 7W from it. I don't want that 7W there, so I can isolate my P's. So I do need to get rid of that 7W. I'm just going to add 7W to both sides of the equal sign. Now I am purposefully putting the 7W far to the right on the right side of the equal sign because it can't be combined with any of those terms. It's not a like term with them. So now my new equation is 5p equals 14y minus 2 plus 7w. Now, just to reiterate what we talked about a couple times ago, I think, is if there were any other terms here that had a w, I would combine it with the 7w. Or if it was 7y, I could combine it with the 14y. But since the letters are different, I can't do it. The last thing I need is 1p, not 5p. So what do I need to do? Divide that by 5. But I'm just going to divide the entire right side by 5 as well to maintain the equality, right? Remember that principle of equality says, well, if A equals B, then A divided by C is also the same as B divided by C. But what is B? Yeah, it can look like 14y minus 2 plus 7w. They were equal in the beginning, and they'll be equal in the end on this one. So I apologize, I got a little long-winded there, but I'm going to write out the whole thing. 14y minus 2 plus 7w all over 5. That actually is the final answer on this one. And again, if that makes you feel a little icky inside, it's something we have to get used to with this. But it should be empowering for you guys because it's like, look what I can do with any equation. If I want to solve for any specific part of it, I can.